Okay, so we will see idempotency at all levels while doing operations inside API calls. So, yeah, idempotency is necessary to be retry safe and for concurrent safety. Okay, so let's consider the example of checkout. Uh, so we are doing it in three steps. Let's consider the final step where the actual order place and payment happens in case the payment method is pay now. Okay, so we are passing idempotency key here, but we should also pass the card data hash. Yeah, so that if let's say somehow the user credentials and device session and idempotency key gets leaked, so in that case we will also check it by request hash, if the request uh, hash is same, as in like the we will pass the card data hash in the input here. Okay, so I have only used the idempotency key. So first we will validate for its correctness, then we will validate checkout if it belongs to this user and if it is still active, and yeah, if it uh, yeah, so then we will try to take a look on idempotency key. So here, it is possible that the look may not be acquired. This look is so that other concurrent requests or retries won't try to operate on the same key. For right now, like this is not already inserted, so yeah, we will take this PG advisory look. Otherwise, we can take the direct exclusive look if it was an already existing entry, if there was already existing entry in the DB with that identifier. Okay, so yeah, this is also equally fine. So yeah, uh, here we can do is like if the look is not acquired, that means that is a retry or a concurrent request. So we can do is like short circuit it here only, uh, and in the short circuit we can check, wait for some time and then check if the data is present. Yeah, so but yeah, like it is not necessary here, so we can move forward, like we can let the concurrent request proceed up until here. So first of all, we will check by I key, like if the data is present. So if the I key row is present, and then we will check if the response body is also present related to that I key. So if the response body is present, we will just return it from here. And if there is no I key ID present, that means when we try to get it from here, like if there is any entry record in DB for that, so yeah, that means nothing exists, so we will try to insert. So here until concurrent requests are allowed, right? So uh, it can happen that both try to insert, but the second request or other request will fail with one conflict do nothing. So we will not receive IK because on conflict do nothing. So if not IK then what it will do is we will try to check, like wait for some time. I mean, this is for concurrent requests. So or retries on the same endpoint call. So yeah, then we will check if it is present and if response is present. Okay, so yeah, if response is present, then return it. But it may also be possible that up until now the request hasn't completed the processing. So in that case, what I have done is I have allowed the request to proceed through, like the concurrent request. Uh, so yeah, that is also fine that I can allow them to proceed through, uh, because all the other steps are idempotent only. Uh, but yeah, like better thing is to like even if after checking this, and even at here, like we in the case of retry or concurrent request, the data couldn't be found here, so we can short circuit the concurrent request, okay, and send to client the identifiers by which they can check, like they can check the status by idempotency key on the status API endpoint, okay. So yeah, uh, that, and okay, so but there is one more thing, that we have short circuited the retries or concurrent request, but it may be possible that even the first request couldn't complete the request. So at that case, first thing is, like if it got posed here, only posed in the sense that network disconnection, so even the first request couldn't complete, so that means that it is not even placed, so only the IK record exists in pending state, so it will be GC'ed later, okay. So we can inform to the client, uh, yeah. And there is one more thing, like it may be possible that the first request completes up until there, like it records the order place in the pending state and DB, okay, but before making a PSP call to payments provider to get the deep link, which will later be used to call the UPI app. So like here it will, PSP will record the pending state and it will send the deep link, but it may be possible that the first request gets disconnected here. So in that case, for such cases, we can add some worker which will try to check the pending states, and yeah, then try to call PSP for that, okay. Or we can just simply ignore that and inform it to client, okay. So yeah, like we can do it both ways, uh, yeah. So that means because if there are loads of requests that came to this endpoint, we cannot control it, that which response gets sent to the client, like all of the responses may be sent to client, so the later responses will override the, like not override, if the client already captures the first response, yeah, then they will proceed through it. But yeah, it may be possible that the first one response wasn't sent, and the response from the concurrent request got sent to the client, which short circuits. So yeah, but then client can check on the status endpoint, okay. So yeah, that okay. So this here I have allowed concurrent requests to proceed through, yeah, but we should short circuit them. So yeah, and then client can check the status on the status endpoint, okay. And yeah, like what was it? Okay, here place order with item. It is like I have not done idempotency at just the orders level. So if I have allowed the concurrent request to proceed through, so it may happen that they create double pending states, uh, and try to create pending states in PSP provider as well. Uh, but yeah, like pending states will obviously be GC'd later, but it adds more overhead. So first thing is, like we will only uh, short circuit concurrent request before reaching this point. So it is not necessary, like because we are short circuiting the double request, or like any request that came after the first request. So like for payments we need to be very safe, so yeah, we won't allow them to proceed through. But even if we allow, so for that we should make this, like the all other things, they are idempotent by itself, even at single level, like order item is idempotent, and this record payment and it pending, and all of this is also like on conflict do nothing. So we can add some unique or combination of unique fields in this orders table so that on conflict it doesn't create double inserts. Okay. Uh, okay, so that is just for this, because all other later insertions are done idempotently via some unique constraints in DB. Okay, so yeah, but first of all, it is that we always make sure that in the client side itself that user can't send double requests, because we send some we uh, disallow double clicking, but again, even then we have to make them concurrent safe. So yeah, that thing. So yeah, we can show okay the concurrent request or retries like here at after this point here. Okay, so yeah, so also yeah, as I discussed we discussed earlier, so we it can happen that here for like the request completed up until here only. So in this case, this payment intent, like this PSP call, won't be completed. So yeah, we can add some worker which polls the pending states and then does this. Okay, but yeah, we can do another thing as well, that if it is like up until here, we if they are in pending states, so yeah, we can just cancel them or GC them, because nothing was completed, they were just in pending states. Okay, but usually there are no network issues, so it just happens that everything gets completed in one call only. And yeah, it is made sure from client side that clients users cannot do double retries, etc., for the very for the endpoints that needs to be extremely safe, like which needs to be called um, um, in a safe manner. So after it gets a deep link, it will it this will try to simulate UPI call. So yeah, here the actual payment processing will happen. Up until here, the PSP only records pending states, like it has received the order intent, and that uh, and in this also, like we will retry the PSP calls few times and record the payment attempts in the table in case of network issues or such things. So yeah, also Razorpay, it is like even if we pass idempotency key, so it will create new pending events, but that is okay, like because those are just in pending state. um, and yeah, like Stripe accepts idempotency key, so there if we pass even same yeah, like there if we retry, then too it won't create double pending states. So but yeah, both are safe only, like just creating pending states uh, is okay, uh, because there is no actual processing here. Okay, and yeah, after it completes, the UPI app completes, then it needs to respond to server that about the status. Okay, so here we will check the status, and this we can put it in environment file. I have just directly added it here for simplicity, like this callback URL. I mean, instead of us asking the PSP provider status again and again, it is better that PSP retries by itself uh, to send status here. Okay, yeah, so um, we will verify the signature, and we will check the webhook status. So if in cases like the provider event ID is not received, so we'll mark the webhook received, and yeah, uh, for the razor pay, it happens in, like it was mentioned in the docs, that uh, if there is no response, if there is no 200 okay response uh, from this URL call, so the PSP will try to send payload here again to update the status. So yeah, if within few minutes, if the PSP doesn't get the response in okay state, like even if we send it in error state, so it will retry. So in such cases, like if not provider ID, or if not order ID, or if not provider payment ID, if such critical details are missing, so in that case we can retry a few times, like maybe uh, yeah, retry a few times, and even if it doesn't, then we will mark the webhook as received, so that the PSP stops retrying. Okay, and we will also record it in DB, so that we can later reconcile it. Okay, uh, because yeah, this shouldn't happen, but in very rare case, like if it happens, okay. So we will check if it is already processed. Then yeah, here uh, mark it as received. If it is processed, then return it from here only. Otherwise, mark it as, yeah, then we will update the status. And in case of correct success state, like if it is updated, so in the same commit, as we are doing the update order status, in the same commit we will try to add, record more events in the DB. uh, I mean, we will have to emit events here, like the order is confirmed, so that it can be sent for processing, and other things that must happen after this event, like after order confirmation. So that will be some external API calls. So we shouldn't do them in the same call, because first of all, this endpoint should return in some few seconds to the PSP. Otherwise, PSP will start. PSP will again retry. So yeah, then it will. Yeah, for better latency, those tasks which can be deferred for later, we can do them later. So, but we also need to make them durable, that they must be processed eventually, and within reasonable time. So yeah, so we will record those intents in the DB. So like in the same commit, as we are updating order status, in the same commit we will emit those events, record them in DB for durability, so that they will be later processed. Then we will also mark webhook as processed, and then commit it at once, all these three steps. Okay, and now, yeah, like we don't need to publish it here. We can, like, the publisher can directly pull the pending events. But yeah, I'm using in memory queue, so just do it directly here as well. So that is fine. Um, but yeah, like this main thing is done here, like for the durability. So now this publisher will do what? It will like it will take the pending events and add them to the queue. So publisher will get the pending events and then publish to queue. So calling publishing to queue is like an external call. So yeah, and then queue will send it to downstream workers for full processing. So that is also an external call from queue to workers. So this publisher worker, what happens is that there will be many workers, so they will try to operate. So to make it like that, different workers don't operate on same rows, because that would be inefficient. Although it is like concurrent safe, we are doing it in idempotent way. So but even then it is like it will be un like it will be not efficient. So what we can do is like first of all, like just uh, here the status is pending, and the final status will be like uh, done something like that. So the, that but yeah, for the processing, what we can do is we can change it to processing status. And yeah, but this processing status is like not a static status, it is a like dynamic status, and it should be ephemeral. That yeah, so for that what we can do is like we can uh, put a locked until also like lock lock that until some point, okay, so that other workers don't try to process take the same row, okay. So what it will do is like uh, yeah, like this locked until thing in itself is like a processing ephemeral status a state. So we don't need to change it to even processing, we can just rely on directly this uh, status state, okay. So if it is in pending state, then a worker will take the row for processing like publishing. And if it is in like if looked until is not none and it is less than now, so that means it can be reclaimed again because it wasn't processed earlier, okay. It is still in pending state and not in sent state, okay. Yeah, this is for the case like when the worker will try to publish. So it may happen that the worker couldn't even publish to the uh, like to the queue system, and it may also happen that it published but it couldn't respond to us so that we can then update the status to send. So in both of the cases we will need this uh, because yeah, the processing was not the final state, it was a transient state and it is dynamic. So yeah, that's why we are taking like ephemeral status state using the looped until thing so that we can reclaim the rows which are still in pending state and couldn't be processed yeah. So okay, that thing, and when the it is published to the queue, then we will get acknowledgement like here. So then we will just update it to sent state, okay. Now it may happen that there may be exceptions like network issues, so such things we can retry. So we will retry it until few times, okay. So yeah, we will retry it few times, and even if after few retries it doesn't work, so then we will send it to dead letter queue and mark it as failed, okay. So those will be reconciled later, uh, okay. So yeah, something like that. uh, Also now it has been added to queue. Now queue to worker is that part we don't need to do, like queue will make sure yeah, queue will retry safely from its side, so the external queue system will retry, okay. So yeah, but I have added like in memory queue and workers. So here we are processing by ourselves, okay. This is, yeah, this is for the like what we have to do, yeah, record a receipt for fulfillment outbox event. So it is like we will process it, okay. Okay, yeah, this is for the thing that after we have to also do this thing like uh, yeah, stock decrement after the order is placed fully. So we will take a look at that. Like first we will acquire and mark processing short transaction. Like here we won't like this we will do in a separate transaction. Then we will take a separate look again here so that we don't keep the loop state for a long time. Okay, so yeah, with for update like direct exclusive look. So then we will uh, try to operate on those product rows and update their stock. Okay, so that different workers don't try to decrease the stock like multiple times, so that it only gets uh, yeah, so that it is done in a safe way. Okay. Okay, yeah. uh, Also, when we try to call external calls, we cannot do it in the same transaction as the like same transactions, as in here we are just publishing to the queue. So like if we think that okay, we can take an look on the outbox event table which is in pending state, and then we try to publish it to queue under the same look, but yeah, that is unreliable, and also like it adds high latency because we are calling an external call in a locked state. So we may also have to do retries. So yeah, uh, logs should only be taken on the same network and not across networks uh, for better latency, lower latency, and for also like even if we take a log on the pending row and then we try to publish to the queue under the same log, but since uh, it is an external network call, so it will happen that request, the loop will be lost if there is a network loss. So it is not even reliable. So yeah, we can't depend on the loop, and for two reasons like that, uh, on the network loss between two networks, there is some disconnection between the like yeah, I mean, there is disconnection of network while calling the different queue system, which is a separate network call. So the logs will be lost. So it is obviously not reliable. So we have to do it this way. And yeah, like the other thing is like it would also be inefficient. Okay. Um, because we can only do log thing is like it is only across one server. We can guarantee that if that thing happened at like in one single transaction. Okay. Also, yeah, one more thing is like here we are using idempotency key here. So there may be something like the client is sending the idempotency key from their side. So yeah, okay, so it happens that they are storing idempotency key somewhere first generated, then store it, and then call this endpoint. Okay, but what if they lose the idempotency key before receiving the response? Like after receiving the response, obviously they delete the idempotency key, but before receiving the response, if they somehow lose the idempotency key, then yeah, like this call will be lost. Okay. So for that case also, like we can use workers, background workers, or some such processes to check pending states and reconcile them. Okay. So yeah.